Welcome back, everybody. It's been a tremendously eventful day for me. I've just made myself an espresso and I think I'm just about ready to go here. Alright, so for today's video, well, there'll be more videos today, but for this lesson we're going to be looking at multiplying and dividing rational expressions. Okay, and I think we'll just start with a numerical example on how to multiply two fractions together. Okay, so this is going to be completely analogous to what we're going to do with rational expressions in general. So let's start off with this example. Supposing I ask you to multiply 5 over 9 times 18 over 35. Okay, well in this case, you know when you multiply fractions, you just multiply the numerators together and multiply the denominators together. And that gives us this. And at this point, we could multiply these together and start reducing, or just like when we were simplifying, we can just factor the 18, factor the 35 a bit, and then cancel common factors. So really, this is not a big extension of what we did in the last video. And that said, I'm going to keep this video fairly short. And so if I factor the 18 as 2 times 9, like so, and then I factor the 35 as 5 times 7, like so. Now you can see we've got common factors in the numerators and denominators, and we can cancel them out one for one. Cancel a 9 with a 9, and a 5 with a 5, and we're left with 2 over 7. Okay, so let's see what this looks like with rational expressions. I'll start with just an example here. Then I'll do an example of how to divide rational expressions. Then we'll put it all together into one big example. Okay, so supposing I ask you to multiply x squared minus 4 over x plus 1 times x over x squared minus x minus 6. Okay, well the first thing you want to do here is just factor the numerators and denominators. Okay, so it's not quite exactly the same steps that we took here, but the first thing we want to do is just factor the numerators and denominators. This denominator is already factored, as is that numerator. Now this one factors as a difference of squares. X minus 2 times x plus 2. And then this one factors as x minus 3, x plus 2, since minus 3 times 2 is minus 6, minus 3 plus 2 is minus 1. Okay, and now we can form a single fraction, complete the multiplication. Times x, that's what we get in the numerator if I multiply the two numerators together, and we're not actually expanding or anything at this point. I need to multiply that by those two factors, and again we're not really multiplying or expanding them out at this point. Okay, And now you can see we've got common factors of x plus 2 in the numerator and denominator, so we can cancel them out. Sorry, I just looked up at the screen for the first time. I see it's a little bit, let me turn off the LED, see if that helps. I see that's a little bit, oh, that's much better, isn't it? Okay, there we go, problem solved. As I said, the quality would keep improving here. I'm a man of my word. Okay, so just to kind of pick up where we left off there, so we cancel an x plus 2 out from the numerator and denominator, and this just leaves us with x minus 2 times x, which I'll write as x times x minus 2, like so. And then in the bottom, we're just left with x plus 1 times x minus 3. And we're done. Okay, now the last thing we want to do here is just state the domain restrictions. Again, just like before, you just look at the denominators of each fraction throughout the question, or at least the denominators of each of the factored forms all throughout the question. So, you know, starting at the top here, you can see that x cannot equal minus 1 from here, x cannot equal 3 from here, x cannot equal minus 2 from here, and then we don't get anything new anywhere else. So for our domain, we can say x is not equal to minus 1 from that factor, 3 from this factor, and minus 2 from this factor, from the factor we canceled out. Okay, and that's an example of multiplying rational expressions. Now, in general, you know, I'm not going to write this step out. I would just cancel in this step here. I see if I multiply them out, I'll have an x plus 2 in the numerator and an x plus 2 in the denominator. So typically I would just cancel them out at this step right here, rather than writing this extra step. And I would just go from this line to this line. Good. Okay, let's look at a numerical example on how to divide rational expressions. And I'm just going to start a new page here. Okay, so for example, let's do the following division. Let's do 18 over 7 divided by 6 over 21. Okay, so all you have to remember here is when you're doing division, you have to multiply by the reciprocal. In other words, we need to flip this fraction around and do multiplication, which gives us 18 over 7 times 21 over 6. And then at this point, just as we did before, we just multiply straight across, which gives us 18 times 21 over 7 times 6. And then we can factor the 18 as 3 times 6. And we can factor the 21 as 3 times 7. And that will allow us to cancel common factors. Cancel a 6 with a 6 and a 7 with a 7, like so. And we're just left with 3 times 3 is 9. And we're left with 1 down here, which just equals 9. Okay, so that's an example with division. So as you can probably predict here, it's exactly the same with rational expressions. We just multiply by the reciprocal. So essentially, it's exactly the same as the first example we did, but in this case, there'll be one extra denominator to look at for domain restrictions. Okay, so let's give this a shot. For example, let's divide x minus 1 over x minus x squared divided by 3 over x. Okay, so again, the first thing we want to do here is just factor everything that needs factoring. And in this case, there's only really one area that needs to be factored, and that's this one here, this denominator here. And the factoring checklist, again, I said we would keep on talking about this. The factoring checklist says first things first, look for a greatest common factor. And in this case, we have a greatest common factor, or a GCF of x. So we'll just factor that out, which gives us x minus 1 over x times 1 minus x. And then we're dividing this by 3 over x, like that. And now all we need to do is turn this into multiplication, multiply by the reciprocal. Just going to use some extra brackets here around the x minus 1. And now we're multiplying by x over 3. And now we can just start canceling common factors. Okay, so the first one's pretty obvious. We can cancel an x from each of the numerator and denominator respectively. And then here, if you think back to the last video that we did, we could factor a negative 1 out of here and then cancel these as common factors. These are additive inverses. So what we'll do is just cancel, cancel, and that leaves behind a minus 1. And so all together we've got minus 1 over 3 as our final answer. Okay, now in terms of domain restrictions, when you're doing division, you just have to be a bit careful, and this is why. Here we had an x in the denominator, but then we ended up multiplying by the reciprocal, and the x ended up in the numerator. But at a certain point, we are trying to divide by this x, so we would have to say x cannot equal 0, even though it ended up in the numerator here. And the reason for that is, well, we'll talk about the reason for that later. Maybe not, but just remember to check the denominators in each step. Okay, so our domain restrictions, if I look at this step here, you can see I've got an x in the denominator. So I need to say x is not equal to 0. And then this 1 minus x was in the denominator all the way along until we canceled it out. So we have to say x cannot equal 1. Good. Okay, so let's talk about how to multiply and divide these in general. Just give you kind of a general step-by-step process. It's pretty straightforward. Okay, so to multiply and divide rational expressions, we're just going to, 1, factor all the numerators and denominators. And then 2, we're going to perform the indicated operation, whether it be multiplication or division. And then cancel common factors. 3, last but not least, let's look at all the denominators in each step for domain restrictions. Alright, so let's take a look at an example, and I just realized I forgot to jot down the homework pages, but maybe I'll quickly do that. Hopefully you won't be able to see me doing it. I'm just going to minimize this this camera here and try to look at it, but for now let's try the utry on page 287. Okay, we're asked to do this. We're asked to do this following operation. 6x squared plus 13x plus 6 over 8x squared minus 18 and then divide that by 3x squared minus x minus 2 over 2x squared plus x minus 3 and then multiply that by 2x over 2 plus 3x. Good. Okay. I think the first thing we should do here is just factor each numerator and denominator separately. Okay, so we'll just work on all of them on their own and then put everything together at the end. So if I do that, well, let's start at the top here. We've got 6x squared plus 13x plus 6. Okay, it's a trinomial. There's no greatest common factor. And we need to find something that multiplies to 6 times 6, which is 36, and adds to 13. Well, if you do a quick calculation in your head here, you'll see that it's 9 and 4. So I can rewrite this as 6x squared plus 9x plus 4x plus 6. Yeah, I'm going to do the factoring fairly fast here, so hopefully your factoring is in order, because there's going to be a lot of factoring in this question. Okay, now it's a groupable expression now, and I just broke that up like that using the decomposition method. Here my GCF is 3x. Here my GCF is plus 2. And so this factors as 3x times 2x plus 3 plus 2 times 2x plus 3. Remember to do your spot check here. If these factors don't match, you'll need to go back a few steps and see where you went wrong. But now we've got the GCF of 2x plus 3. We're just going to factor it out. I think I might swap out my pencil here. Yeah. I brought many sharpened pencils with me to this one. Okay, let's finish off this factorization here. We've got 2x plus 3 times 3x plus 2. Now that's the final factorization of this numerator. Okay, working on the bottom here on this denominator, what do we have? We've got 8x squared minus 18. So factoring checklist says look for your GCF, and here we have a GCF of 2. Okay, And now we've got a difference of squares that factors as 2x minus 3, 2x plus 3. Well, that's good news. We've already got a 2x plus 3 that's going to cancel out. This one's going to cancel out with this one. Okay, let's continue on here. Let's work on this one here, the 3x squared minus x minus 2. Okay, so again, we need to do the decomposition. We're looking for something that multiplies to minus 6 and adds to minus 1. Well, let's see. Not the quickest on my feet today. It's been a tremendously busy day. Let's see. I feel like it's going to be minus 3 and plus 2. Yes, that seems to work. So remember, we're looking for something that multiplies to minus 6 and adds to minus 1, which is minus 3 plus 2. Okay, let's do the decomposition. We've got 3x squared minus 3x plus 2x minus 2. And again, we can factor this by grouping now. Here our GCF is 3x. Here our GCF is plus 2. Where have we seen that before? I'm going to guess this is going to cancel out as a common factor at some point. So I'm just going to factor out a 3x, which leaves me with x minus 1. I would say stop me if I make a mistake, but you can't really stop me when you're watching a pre-recorded video. Okay, everything looks good here, so now I'm just going to factor out the x minus 1. And that leaves behind a 3x plus 2 like that. Okay, we're getting pretty close here. We've done 1, 2, 3 of them so far, and these two are already factored, so we're good here. Okay, the last one we need to do here is 2x squared plus x minus 3. And, again, I'm looking for something that multiplies to minus 6 here. And it needs to add to plus 1 this time. And this time we're going to do 3 and minus 2. Like so. Okay, so now let's do the decomposition. I've got 2x squared plus 3x minus 2x minus 3. Okay, now here my GCF is x, and here my GCF is minus 1. And that leaves me with x times 2x plus 3 minus 1 times 2x plus 3. Factor out the 2x plus 3. And that leaves behind an x minus 1. Whew. Okay, so this unit, there's a ton of legwork in every question. So just take your time, break it up into pieces, and then you can put everything together at the end. Okay, the last comment I want to make here is this, right here. Okay, remember, 2 plus 3x, well, this is the same as 3x plus 2. Remember, the order you add things in doesn't matter, so I can just rearrange that like so. Okay, let's put together our final product here. Well, I shouldn't use the word product since we're doing multiplying, but let's put together what we've got so far. Okay, so this numerator factored as 2x plus 3 times 3x plus 2. This denominator factored as 2 times 2x minus 3 times 2x plus 3. and then we're dividing by this numerator factored as x minus 1 times 3x plus 2. And this denominator factored as 2x plus 3 times x minus 1. And then the last one, which was already factored for us, is just 2x over 3x plus 2. Remember, that's 2 times x. We're going to end up canceling that with that. So just want to keep track of that. Okay, we're almost there. What we would like to do here now is just do the division, which means multiply by the reciprocal. So we just want to flip this fraction around. And then we'll start canceling common factors. My writing's getting a bit sloppy here. Just want to get this done at this point. Yeah, these are arduous questions. They take a lot of work. Sorry, I'm supposed to be flipping that. So I've almost made a typo there. Fortunately, there was an x minus 1 down there. So this is x minus 1 times 2x plus 3. And now this one goes on the bottom. X minus 1 times 3x plus 2. And then, last but not least, we're multiplying by 2x over, excuse me, 3x plus 2. Okay, throat's getting a bit raspy here. I've got an espresso here. Gonna drink my Nespresso, take a quick sip of it, and then we'll finish the question. Alright, so as I said, it's just a matter of canceling common factors here. Remember, cancel them one for one. So here I've got a 2x plus 3 and a 2x plus 3. Those go away. And I spotted this a few steps ago. Obviously, these x minus 1s will cancel out. We've got a 3x plus 2 here and here that cancel. And then, I feel like I want these to cancel, but probably not. So the last thing we can cancel out here is 2 and 2. And this leaves us with, if we complete the multiplication, remember you just multiply straight across. This just leaves us with, well, we just have x times 2x plus 3 in the numerator. And then we've got 2x minus 3 times 3x plus 2 in the denominator. Okay, now in terms of domain restrictions, you need to check each denominator. This one, 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 and this one in particular. So, you know, after this step, this denominator turned into a numerator, so you need to make sure you check all of them. Yeah, and I'll let you guys do that. The answer is on page 287. So make sure you can do that. Go to page 287 to check your answer. Good. Okay, that concludes this video. The next video will be on least common denominators, or least common multiples of polynomial expressions, and then we'll move into adding and subtracting polynomial expressions. Have a good evening.